Berlin, March 1944. 2:17 a.m. Hermann Göring's hand trembled as he held the intelligence report. Not from age, he was only 51, but from something far more corrosive than time, the slow-motion collapse of certainty. The numbers on the page refused to change no matter how many times he blinked. One bomber every 63 minutes from a single factory. The Reichsmarshal had built his career on impossible boasts. He'd promised Hitler that not a single enemy bomb would fall on Berlin. He'd sworn the Luftwaffe would starve Britain into submission. He'd declared American industrial capacity a myth, a Hollywood illusion projected onto the world stage. Now, in the pre-dawn darkness of his office, surrounded by Baroque furniture looted from France, Göring confronted a truth more devastating than any military defeat. America wasn't just beating Germany. America was making the very idea of German victory mathematically impossible. Outside his window, Berlin slept uneasily under blackout curtains. In 36 hours, 730 American bombers would paint the morning sky with contrails, and Göring's Luftwaffe would shoot down perhaps 40 of them, a respectable kill ratio by any measure, except for one problem. In those same 36 hours, American factories would have already replaced every single downed aircraft and built 17 more besides. The war, Göring realized with the clarity that comes only in the hollow hours before dawn, was not being lost in the skies over Germany. It was being lost in a converted automobile plant outside Detroit, where the impossible had become routine, and where German strategic assumptions were being demolished, one B-24 Liberator at a time, every single hour, around the clock, 7 days a week. Washington, D.C., December 8, 1941. 24 hours after Pearl Harbor, while America reeled from the shock of burning battleships and shattered isolationism, a different kind of calculation was taking place in a nondescript office building 3 blocks from the White House. William Knudsen, former president of General Motors and now director of the Office of Production Management, sat across from a young Army Air Corps colonel named Charles Lindbergh, Jr., not the famous aviator, but his distant cousin, an engineer who specialized in what the military called industrial capacity analysis. The colonel had brought a problem that seemed to violate the laws of physics. "They want 18,000 heavy bombers," Lindbergh said, sliding a requisition form across the desk. "By the end of 1943, that's 2 years, Mr. Knudsen. 2 years to build more 4-engine aircraft than currently exist in the entire world." Knudsen didn't look up from the document. His thick fingers, stained with decades of machine oil that no amount of soap could completely erase, traced the numbers like a priest reading scripture. 18,000 B-24 Liberators, each one requiring 1.2 million parts, each one representing 360,000 man-hours of labor, each one costing $215,516 in 1941 dollars, more than most Americans would earn in 20 lifetimes. 2 years, Knudsen repeated, finally meeting the colonel's eyes. That's 750 bombers per month, 25 bombers per day. He paused, doing mental arithmetic that would have impressed a differential calculus professor. 1 bomber every 57 minutes, working around the clock. "Exactly," Lindbergh said, "which is why I'm here to tell you it's impossible. The entire American aircraft industry built 5,165 planes total last year. You're asking us to build 3 times that number of just one model in a single year, while also ramping up production of fighters, transports, and trainers. The bottlenecks alone." Knudsen held up one hand. "Tell me something, Colonel. Have you ever seen an automobile assembly line?" "Sir?" "Henry Ford's Highland Park plant, River Rouge, the Chrysler Jefferson Avenue facility. Have you watched them build cars?" No, sir. I'm an aeronautical engineer. I build planes, not that," Knudsen said, his thick Swedish accent giving the word an almost biblical weight, "is your problem. You think planes and cars are different? They're not. They're both just parts. Complicated parts, yes, many parts, certainly, but still just parts. And if you can figure out how to bring the parts to the worker instead of the worker to the parts—" He smiled, a knowing expression that had made General Motors executives both wealthy and nervous. "Then you can build anything, at any speed. You just need to stop thinking like an engineer and start thinking like a machine." The colonel left Knudsen's office unconvinced. In his report to the War Department, he recommended scaling back the bomber program to realistic targets of perhaps 8,000 aircraft by 1944. The report was filed and forgotten. Knudsen, meanwhile, picked up his telephone and placed a call to Dearborn, Michigan. Henry Ford answered on the third ring. Ypsilanti Township, Michigan, January 1942. The site chosen for what would become the Willow Run Bomber Plant had, until 6 weeks earlier, been 980 acres of farmland, winter wheat stubble poking through dirty snow, a landscape so unremarkable that even local residents struggled to remember what had grown there. It sat between a slow-moving creek and the Detroit-Toledo Highway, flat as a drafting table, close enough to Detroit's manufacturing ecosystem to draw on its skilled workforce, but far enough away that if catastrophe struck, an errant bomb, a sabotage explosion, it wouldn't cripple the entire automotive industry. Charles Sorensen, Ford's production chief and the man who'd actually designed the moving assembly line that made Henry Ford famous, stood at the site on a morning when the temperature hung at 7 degrees Fahrenheit. He was 61 years old, a Danish immigrant who'd spent 40 years turning Henry Ford's intuitions into steel and concrete reality. Now he faced the most audacious assignment of his career: design a factory to build the most complex machine in military history using methods developed to manufacture Model T Fords. The B-24 Liberator bomber in its current configuration consisted of 1,250,000 individual parts. It had a wingspan of 110 feet, longer than the Wright brothers' first flight. It weighed 36,000 pounds empty, 65,000 pounds fully loaded. Its 4 Pratt & Whitney R1830 twin Wasp engines generated 1,200 horsepower each. It carried 10 50 caliber machine guns, a crew of 10 men, and enough fuel to fly from England to Berlin and back. Currently, in early 1942, America's aircraft manufacturers could build one B-24 in approximately 30,000 man-hours, or roughly 3.5 weeks of round-the-clock work. Ford's assignment was to reduce that to 18,000 man-hours, and then keep finding ways to cut the time further. Sorensen walked the frozen farmland, mentally sketching the largest room under one roof ever conceived by human beings. The building would need to be half a mile long, 2,080 feet of continuous production floor. It would need to be 1,280 feet wide. It would enclose 3.5 million square feet of space, enough room to fit 459 baseball fields or the entire Yankee Stadium 42 times over. The roof alone would require enough steel to build 60 Sherman tanks. But size wasn't the real innovation. The real innovation was flow. In traditional aircraft manufacturing, a bomber moved through construction like a patient through surgery. It remained stationary while teams of specialists swarmed around it, each group completing their tasks before the next arrived. Wing assembly here, fuselage there, engines somewhere else. Final assembly requiring the delicate mating of major components built in different buildings, sometimes different cities. Sorensen envisioned something radically different. The airplane would move, constantly, inexorably, down a production line 2,180 feet long. Parts would flow to the aircraft from feeder lines arranged like capillaries feeding an artery. Workers would stay in place, each performing the same specialized task thousands of times. The bomber would enter as a pile of components and emerge 63 minutes later, ready to fly across the Atlantic and drop 8,000 pounds of high explosive on someone's homeland. "It's insane," said Edsel Ford, Henry's son and the company's nominal president, when Sorensen presented the plans in February. "You're trying to build a building larger than the Pentagon, which isn't even finished yet, in 6 months. You're proposing to use assembly line techniques on a machine that has 4 times as many parts as a B-17, which Boeing itself says can't be mass-produced. And you want to do this while the automotive industry is simultaneously converting to build tanks, jeeps, and aircraft engines. Charles, even for you, this is going to work," Sorensen interrupted. "Because it has to. Because if it doesn't, we'll be speaking German by 1946. And because, Mr. Ford, your father doesn't take kindly to the word impossible." Construction began on April 18, 1942, the same day that Jimmy Doolittle's B-25s bombed Tokyo. While America celebrated its first offensive blow against Japan, 12,000 construction workers descended on a muddy field in Michigan and began building the instrument of Germany's industrial doom. Berchtesgaden, Germany, summer 1942. Albert Speer, newly appointed Minister of Armaments and War Production, understood numbers the way a concert pianist understands keys, not just their individual values, but their relationships, their harmonies, their capacity to create complex symphonies of meaning. At 37, he was the youngest minister in Hitler's cabinet, a trained architect thrust into industrial management by the chaos of total war and the Führer's faith in aesthetic vision over technical expertise. The intelligence reports on American industrial capacity sat on his desk like an unexploded bomb. American steel production, 81 million tons in 1941. Germany's, 31 million. That was the fundamental equation from which all other calculations flowed. Steel was calories. Steel was possibility. Steel was the material grammar with which modern war spoke its terrible sentences. But Speer, trained to see space and form, understood something his purely technical advisors missed. Production wasn't just about raw materials. It was about organization, efficiency, the intelligent arrangement of human effort. Germany had advantages that raw numbers didn't capture. German workers were disciplined, educated, experienced in precision manufacturing. German engineers were superb, perhaps the finest in the world. And most critically, Germany was focused. America would need to divide its production between two theaters, Pacific and European, while simultaneously maintaining its bloated civilian economy. They won't commit, Speer told Field Marshal Wilhelm Keitel during a meeting at the Berghof, Hitler's mountain retreat. Americans are consumers, not producers. They think in terms of comfort, not sacrifice. Look at their proposed conversion targets. They're still planning to build 3.9 million civilian automobiles in 1942. In wartime, we've completely ceased passenger car production. Every factory, every worker focused solely on the war effort. Keitel, professional soldier and Hitler's yes man, nodded sagely. And their industrial workforce, riddled with strikes, union agitation, Negro workers who— "That's not the point," Speer interrupted. He had little patience for Nazi racial ideology when it interfered with practical analysis. The point is organizational. The Americans practice what they call consumer capitalism. This makes them excellent at producing variety. Hundreds of car models, washing machines, refrigerators, all the comforts of their decadent society. But modern war requires standardization, focus, the ability to produce one thing in massive quantities. This is antithetical to the American industrial psyche. He pulled out a report on the B-24 Liberator program. Look at this. They're proposing to build these bombers in 5 different factories. Consolidated in San Diego, Douglas in Tulsa, North American in Dallas, and now Ford in Michigan. Each plant will use slightly different manufacturing methods, different subcontractors, different supply chains. It's chaos posing as industry. We would never organize production this way. What Speer didn't say, what he perhaps didn't fully realize, was that this apparent chaos was precisely the point. Decentralization meant resilience. If one plant was destroyed, 4 others continued. Different methods meant different innovation vectors. Competition between contractors drove efficiency improvements. The apparent disorder of American capitalism was, in fact, a supremely adaptive system that Nazi central planning, for all its surface logic, could never match. But in summer 1942, these advantages remained theoretical. The Battle of Midway had just been fought. Rommel was advancing in North Africa. German U-boats were sinking 700,000 tons of Allied shipping per month. The Luftwaffe still controlled European skies. The war seemed balanced on a knife's edge, and Speer's calculations, meticulous, logical, rooted in the industrial realities of 1942, told him Germany could win if it could just maintain its production lead for 18 more months. He was right about the timeline. He was catastrophically wrong about who would maintain the lead. Willow Run, Michigan, September 1st, 1942. The first B-24 to roll out of Willow Run was a lie. Or more accurately, it was a theatrical production masquerading as industrial achievement. The fuselage had been built at Consolidated's San Diego plant and shipped east by rail. The wings came from Douglas in Tulsa. The engines were Pratt & Whitney units manufactured in Hartford, Connecticut. Willow Run's contribution consisted primarily of final assembly, bolting together major components built elsewhere, installing wiring and hydraulics, testing systems. The bomber took 2 weeks to complete. Charles Sorensen, watching from the observation gallery as newsreel cameras rolled and Ford executives applauded, felt a complex mixture of pride and shame. Pride because Willow Run existed at all. In just 5 months, they'd erected the largest manufacturing facility on Earth, recruited and trained 14,000 workers, and actually produced a functional aircraft. Shame because he knew what the newsreels wouldn't show: the chaos behind the pageantry, the bottlenecks that paralyzed production, the fact that this one aircraft represented not the beginning of mass production, but merely the end of the beginning. The problems were legion. Parts arrived late or not at all. Subcontractors who'd promised precision components delivered garbage that wouldn't fit. Workers trained on automobiles struggled with aircraft assembly's tighter tolerances. The assembly line itself, revolutionary in concept, revealed unanticipated problems at every station. A jig designed to hold wing sections proved too weak. Wings sagged, creating gaps that required hours of careful shimming. The massive overhead cranes that moved fuselage sections occasionally dropped their loads, transforming a month's work into twisted aluminum in seconds. And then there was the simple, crushing reality of scale. Building one B-24 required 450,000 rivets. Each rivet needed to be precisely sized, properly aligned, driven to exact depth, and inspected. At current speeds, Willow Run employed one inspector for every 3 riveters, and the inspectors were finding error rates of nearly 15%. Multiply that across 1.55 million parts, and you had a recipe for either catastrophic failure rates or production speeds that made traditional methods look efficient. By October 1942, Willow Run had built a total of 7 aircraft. The goal had been 56. Will it work? Edsel Ford asked Sorensen one evening as they walked the production floor after the shift change. The building was never truly silent. Maintenance crews worked around the clock, and the ventilation systems hummed like a living thing. But without 14,000 workers, it felt almost sepulchral, a massive aluminum cathedral waiting for its faithful to return. "I don't know," Sorensen admitted. He was not given to false optimism. "We're fighting the learning curve, fighting the supply chain, fighting ourselves. Every day we discover something we got wrong, some assumption that seemed logical in theory, but collapses in practice. The turret installation sequence alone has been redesigned 4 times. So it's possible we've built a half-mile-long monument to failure? No." Sorensen's voice carried absolute certainty. "We've built a half-mile-long experimental apparatus. Edison didn't invent the light bulb on his first try. He invented it on his 1,000th try. Each failure taught him something. We're failing faster than anyone in history, which means we're learning faster than anyone in history. The question isn't whether we'll solve these problems. The question is whether we'll solve them in time. In time for what went unspoken, but both men understood. In time to matter. In time to save civilization from mechanized barbarism. In time to prove that democracy and free markets could outproduce totalitarianism and central planning. In time to make Goering's arithmetic apocalyptic. Willow Run, January to June 1943. The breakthrough came not from engineering genius or heroic effort, but from the grinding, unglamorous accumulation of 10,000 small improvements, each one shaving seconds off the production cycle, each one making the impossible slightly less impossible. Station 127, where the nose section mated with the forward fuselage, had been a persistent bottleneck. The operation required 12 workers using pneumatic wrenches to install 240 bolts in a precise sequence. Any deviation created stress fractures that would eventually catastrophically fail. The station could process one aircraft every 8 hours, which meant that no matter how fast earlier stations worked, the entire line could never exceed 3 aircraft per day. The breakthrough came from a 42-year-old former automotive worker named Rosie Betts, though the propaganda posters would later immortalize her as Rosie the Riveter, an amalgam of several real women transformed into nationalist iconography. Betts, whose husband was serving with the 82nd Airborne in Italy, had worked at the River Rouge plant before transferring to Willow Run. She understood something about the nose section problem that the aeronautical engineers didn't. It wasn't an aircraft problem, it was a positioning problem. "You're bolting the sections together wrong," she told the station supervisor one morning. "You're treating it like it's delicate, like you're afraid to force it. But these tolerances," she tapped the engineering drawings with a calloused finger, "they're too tight. They don't account for thermal expansion or slight variations in the aluminum. You need to pre-stress the sections." "Pre-stress? That'll create microfractures." "No," Betts interrupted. "It'll create controlled distribution of load-bearing stress across the entire joint. Trust me, I watched us bolt engine blocks to chassis for 6 years. Same principle, just different scale." The supervisor, desperate enough to try anything, authorized a test. Betts and her team modified the jigs to apply slight compressive force before bolt installation. The result? Assembly time dropped from 8 hours to 90 minutes, and structural testing showed the joints were actually 30% stronger than standard specification. Multiply that improvement across 312 production stations, and you begin to understand how Willow Run transformed from industrial disaster to industrial miracle. By March 1943, the plant was building 1 bomber per day. By April, 2. By June, the line was running fast enough that a new B-24 emerged every 4 hours. Still short of the goal, still behind schedule, but the trajectory had shifted from impossible to merely improbable, and the Germans were beginning to notice. Luftwaffe Intelligence Headquarters, Berlin, July 1943. Major Hans Bauer specialized in what the intelligence community called industrial capacity analysis, the dry mathematical discipline of estimating enemy production capabilities based on factory size, workforce numbers, raw material imports, and electrical consumption. It was detective work performed with slide rules and logarithmic tables, where the clues were shipping manifests and aerial reconnaissance photographs rather than bloodstains and fingerprints. The photographs of Willow Run made no sense. The facility itself was impressive. The reconnaissance Bf-110 had made 2 passes at 32,000 feet, high enough to avoid American fighters, and the resulting images showed a structure so large that Bauer initially thought the scale annotations were wrong. But even granting the building's unprecedented size, the numbers didn't work. Aerial photography could reveal much about a factory's output. You could count trucks entering and leaving. You could estimate worker population by analyzing parking areas and calculating person hours. You could track railroad cars and extrapolate material inputs. Taken together, these data points created a statistical portrait of production capacity. According to Bauer's calculations, Willow Run should be producing approximately 4 bombers per month. Respectable for a new facility, nothing apocalyptic. But American bombers were appearing over Germany in numbers that made 4 per month mathematically impossible. RAF intelligence, which the Luftwaffe grudgingly respected, estimated that the Americans were now building nearly 700 B-24s monthly, and the numbers were accelerating. If correct, that meant Willow Run alone was producing, what, 50 bombers per month? 100? Bauer checked his calculations 3 times. He consulted with colleagues. He reviewed every available intelligence report on American aircraft production. The numbers refused to cohere. Either the Americans had discovered some revolutionary manufacturing technique that violated every known principle of industrial organization, or they were building fake bombers to inflate their apparent capacity. The third possibility, that Bauer's entire framework for understanding industrial production was wrong, seemed too disturbing to seriously consider. He filed his report in July 1943, noting the discrepancy and recommending further investigation. The report reached Albert Speer's desk in August. Speer, like Bauer, initially assumed an analytical error. But Speer had the advantage of broader context. He could see the entire industrial picture, American steel production now exceeding 90 million tons annually, American aluminum production dwarfing Germany's entire output, American shipyards now launching cargo vessels faster than U-boats could sink them. A terrible suspicion began forming in Speer's precise architectural mind. What if American industrial methods weren't just different from German methods? What if they were fundamentally superior? What if decentralized chaos actually outperformed centralized planning? What if consumer capitalism, that system Speer had dismissed as soft and undisciplined, was actually evolving into the most formidable production machine in human history? He requested updated intelligence on Willow Run specifically. The response came in October, and with it, certainty became dread. Willow Run, Michigan, March 1944. The production board in the main office displayed 3 numbers in white chalk on black slate. Goal: 1 char current, 1 to 63 Mindauer total, 3,742 one bomber every 63 minutes. The line now ran with a precision that would have seemed supernatural 2 years earlier. At the beginning of the mile-long assembly process, workers laid the keel, a single aluminum beam that would become the aircraft's spine. 63 minutes later, at the far end, a complete B-24 Liberator rolled out onto the tarmac, engines installed, guns mounted, fuel tanks pressurized, ready for test flight. Rosie Betts, now a line supervisor, walked the production floor with a stopwatch and clipboard, timing each station, looking for inefficiencies. She'd become expert at spotting the micro delays that accumulated into macro problems, a bolt basket positioned 6 inches too far from the optimal reach point, costing workers 2 seconds per installation. Multiply by 450 bolts, multiply by 24 aircraft per day, and those 6 inches translated into 4 lost work hours daily. The psychological shift among workers was as important as the technical improvements. In early 1943, building bombers had felt like manufacturing artifacts, each one a discrete achievement. Now it felt like operating a machine, where each worker was a component in a vast clockwork mechanism. Individual bombers lost their distinctness. They became units, numbers, abstractions. Which was precisely the point. Charles Sorensen, now 63 and increasingly frail, understood what they'd created. A machine for transforming American industrial capacity into German strategic despair. Every 63 minutes, another 4-engine symbol of inevitability rolled off the line. Every 63 minutes, Germany's mathematical chances of victory shrank by a calculable fraction. The bombers themselves told a story through their serial numbers. The early aircraft from late 1942 bore scars of their difficult birth. Irregular rivet patterns, hand-fitted panels, countless small variations that marked them as works of evolving craft. By contrast, bombers built in March 1944 were identical to within microns, their components interchangeable, their construction so standardized that a wing built on Monday would fit perfectly on a fuselage assembled on Friday. This interchangeability had profound military implications. Damaged bombers could be cannibalized for parts in the field. Maintenance became simpler, faster, more reliable. The entire 8th Air Force logistics system simplified because every B-24 was, fundamentally, the same B-24. But the most important effect was psychological, and it struck not the Americans, but their enemies. Berlin, March 1944. Hermann Goering read the intelligence report at 2:17 a.m. because he could no longer sleep. The morphine addiction that would eventually destroy him had already begun its work. But in early 1944, he was still functional, still rational enough to understand what the numbers meant. Willow Run, 1 bomber every 63 minutes. 4 other American plants, combined production of 2 bombers per hour. Total American heavy bomber production approximately 60 per day. German fighter production, all types, approximately 40 per day. German heavy fighter, the only type truly effective against B-24s, 8 per day. The arithmetic was apocalyptic. Even if every German fighter shot down 1 Allied bomber before being destroyed, an impossible ratio, Germany would still lose. Because tomorrow, 60 more bombers would arrive. And the day after, 60 more. And the day after that, an inexhaustible flood of aluminum and steel, each aircraft carrying 8,000 pounds of high explosive, each one crewed by 10 Americans who'd replaced the 10 who'd died yesterday in an apparently infinite cycle of industrial regeneration. Goering's strategic reserve of fighters, the units he'd been hoarding for some imagined decisive battle, numbered approximately 2,400 aircraft. At current attrition rates, that reserve would be exhausted in 90 days. And then Germany's skies would belong to America, absolutely and irreversibly. He'd built the Luftwaffe on the principle of tactical superiority, better training, better aircraft, better pilots producing local advantages that could be exploited for strategic gain. That doctrine had worked brilliantly in Poland, France, Norway. It had nearly worked in Britain. It had definitely failed in Russia, where Soviet production, crude, inefficient, but overwhelming, had simply absorbed German tactical excellence and ground it into statistical irrelevance. Now America was demonstrating that you could have both quantitative superiority and qualitative excellence. The B-24 was not a crude weapon. It was sophisticated, reliable, capable, flown by crews who'd trained for 18 months, navigated with precision equipment, defended by escort fighters that were, increasingly, superior to anything Germany could field. And most horrifying of all, replaceable, infinitely, inexhaustibly replaceable. Goering had promised Hitler that American production figures were propaganda, that the reported numbers couldn't possibly be real, that German intelligence had been deceived by Allied disinformation. He'd built an entire strategic framework on the assumption that America would tire, that democracy would fracture under wartime stress, that the soft consumer society would prioritize comfort over victory. Every assumption had been wrong. He thought about the Willow Run Plant, that converted automobile factory in Michigan. He'd dismissed it as typical American inefficiency, using civilian methods for military production, employing women and untrained workers, relying on mechanical assembly rather than skilled craftsmanship. He'd assumed it would produce inferior aircraft at modest rates. Instead, it was producing superior aircraft at rates that made German production look artisanal. The telephone on his desk rang. It was Albert Speer calling from his ministry. Neither man remarked on the hour. Neither slept normally anymore. "You've seen the new figures," Speer said. Not a question. "I've seen them. We need to present alternatives to the Führer, options that acknowledge the production disparity without—" "There are no alternatives," Goering interrupted. "The arithmetic doesn't allow alternatives. If we had 3 years, perhaps, if we could relocate our aircraft plants underground, disperse production, develop jet fighters on an accelerated timeline, we might achieve parity by late 1946. But we don't have 3 years. We have months." Silence on the line. Then, "So we lose." "No." Goering's voice hardened. "We lose the production war. The actual war might still be winnable, but only through methods we haven't yet employed. Decisive action against specific targets. Political operations to fracture the alliance. Technologies that change the fundamental calculus." He meant, though he didn't say it explicitly, the atomic weapons research that Germany had abandoned as impractical, the V-weapons that might terror bomb London into submission, the jet fighters that might, possibly, restore German aerial supremacy. Desperate gambles, all of them. But when arithmetic itself becomes your enemy, desperation is all that remains. The conversation ended. Goering returned to his intelligence reports, reading them with the grim fascination of a man watching his own execution approach. The numbers didn't change. They never would. In Michigan, another B-24 rolled off the line. 63 minutes later, another. Then another. Then another. A mechanical heartbeat that would not stop, would not slow, would not show mercy. The arsenal of democracy had awakened, and it was hungry. Over Germany, May 1944, Lieutenant James McCarthy, bombardier on Lucky Strike, a B-24 from the 458th Bomb Group, didn't know about Willow Run's production statistics. He didn't know about Goering's sleepless nights or Albert Speer's crisis of strategic faith. He knew only that his was the 33rd mission, that the odds of surviving the required 35 were approximately 40%, and that the flak over Schweinfurt, their target today, was the most intense in the European theater. The bomber shook as an 80 Liberator shell exploded 50 yards off the port wing. Fragments punctured the fuselage with sounds like hammers striking tin. The aircraft ahead of them, Memphis Gal, took a direct hit to the No. 3 engine. Fire bloomed orange, then black as fuel ignited. The crew bailed. McCarthy counted 8 parachutes, maybe 9, and the bomber entered its final dive, a meteor of aluminum and lost futures. 3 months earlier, losing Memphis Gal would have meant a 0.01% reduction in operational bomber strength, a meaningful loss. Now it meant approximately 63 minutes of Willow Run production. By tomorrow morning, the replacement would already exist. By next week, it would be in England. By the week after, it would be flying over Germany with a new crew, a new name painted on the nose, but fundamentally identical to the aircraft falling in flames beneath them. This was the reality that German fighter pilots confronted daily. Shooting down Allied bombers had become strategically meaningless. Tactically, yes, they saved German cities from that specific bomb load. But strategically, the bombers would return tomorrow and the day after, in numbers that made German resistance feel like bailing ocean with a teaspoon. Lucky Strike released its bombs at 22,000 feet. Through the Norden bomb site's optics, McCarthy watched the factory complex below, a collection of rectangular buildings that reconnaissance photos suggested manufactured ball bearings. The bombs fell in neat patterns, each one a mathematical expression of industrial might. Not just the explosive payload, but everything that payload represented: the bauxite mines in Arkansas, the aluminum refineries in Tennessee, the explosives plants in Indiana, the fuses manufactured in Connecticut, the entire continent-spanning supply chain that could transform dirt and electricity into 8,000 pounds of high explosive delivered precisely on target 5,000 miles from home. And it could do this 60 times per day indefinitely until Germany's industrial capacity was reduced to rubble and memory. Essen, Germany, March 1945. Albert Speer toured the Krupp works with the detachment of a surgeon examining a patient he knows he cannot save. The factory complex, which had employed 120,000 workers at its peak, now operated at 23% capacity. Not because workers had fled or materials were unavailable, but because Allied bombing had destroyed the electrical grid, the rail connections, the supplier network that turned raw steel into precision machinery. The mathematics of collapse followed predictable patterns. Destroying a factory required concentrated effort, hundreds of bombers, thousands of tons of explosives. But destroying the infrastructure that connected factories to each other, that required only persistence. Cut rail lines faster than they could be repaired, crater marshalling yards, demolish bridges, make transportation itself impossible. American bombers, built in Michigan at rates that still seemed hallucinatory, had achieved something more devastating than destruction. They'd achieved disruption at a scale that made recovery impossible. Germany could rebuild factories. It couldn't rebuild an entire industrial ecosystem while simultaneously being bombed around the clock. Speer had written a memo to Hitler in January admitting the obvious: the war was lost. Not might be lost, was lost, grammatically past tense, a completed action. German industrial production had fallen 50% since June 1944. Fighter production, despite Speer's desperate efforts at dispersal and underground facilities, had peaked in September and was now declining monthly. The V-2 rocket program, that monument to technological sophistication, was consuming resources that might have built 50,000 conventional fighters, aircraft that might actually have made a difference. But the memo changed nothing. Hitler lived increasingly in a fantasy world where wonder weapons and Volkssturm militia would somehow reverse the arithmetic, where willpower could overcome industrial capacity, where belief itself was weaponry. Speer knew better. He'd spent 3 years optimizing German production, squeezing every possible advantage from centralized planning and slave labor. He'd increased tank production by 300%, artillery by 250%, small arms by 180%. Impressive figures until you realize that American production had increased by 500% across the board, starting from a higher baseline with a larger workforce, drawing on resources from an untouched continent. The Willow Run Plant, that converted automobile factory, had become for Speer a symbol of everything he'd miscalculated. He'd assumed American consumer capitalism was a weakness. Instead, it had been the ultimate preparation for total war. An entire society that had spent 50 years perfecting mass production, logistics, and supply chain management could pivot to military production with terrifying efficiency. Walking through the damaged Krupp facilities, Speer thought about parallel universes. What if Germany had embraced mass production earlier? What if they'd standardized their weapons systems instead of producing 12 different tank models? What if they'd built 50,000 adequate fighters instead of 5,000 exceptional ones? But these were philosophers' questions. History doesn't grant do-overs. The arithmetic had been completed, the equation solved. Germany had lost the production war in 1942, before Stalingrad, before Normandy, before any of the famous turning points. They'd lost it the moment Charles Sorensen walked across a frozen Michigan field and imagined a building half a mile long. Everything since had been epilogue. Willow Run, Michigan, June 1945. The last B-24 Liberator rolled off the Willow Run line on June 28, 1945, serial number 44-52-400. There was no ceremony. By that point, Germany had surrendered, victory in Europe had been celebrated, and the bomber plant's future was uncertain. Ford had lost money on every aircraft built. The contract had been structured for volume, not profit. And Henry Ford himself, now 81 and declining into senility, wanted the plant converted back to automobile production. The final tally, 8,685 B-24 Liberators in 32 months of full production. The peak rate achieved in August 1944 was one bomber every 59 minutes, better than the goal that had seemed impossible in 1942. But numbers alone don't capture what Willow Run represented. It was proof of concept for a new kind of warfare, where industrial capacity became the ultimate weapon, where logistics defeated tactics, where the ability to replace losses faster than they accumulated made traditional concepts of military efficiency obsolete. Charles Sorensen, retired now and watching from the sidelines, understood that Willow Run had changed manufacturing forever. The techniques developed for bomber production, modular design, interchangeable parts, statistical process control, just-in-time logistics would reshape the post-war world. The workers trained in precision assembly would build America's commercial aircraft industry. The management methods would spread through every manufacturing sector. Most importantly, Willow Run had demonstrated that democracy and free markets weren't just morally superior to totalitarianism, they were practically superior, more efficient, more adaptive, more capable of mobilizing human potential. Hermann Goering, imprisoned at Nuremberg awaiting trial, would eventually be asked about the turning point of the war. He gave several answers depending on his mood. Stalingrad, the failure to destroy the RAF, Hitler's declaration of war on America. But in private moments, when the bravado failed and the morphine wore thin, he would fixate on a single image, that converted automobile plant in Michigan, that impossible factory that had made German victory mathematically impossible. They built a bomber every hour, he told his lawyer, almost wonderingly. For 2 years, around the clock, 7 days a week. We couldn't even bomb the factory. It was 5,000 miles away, completely untouchable. So every day, 24 more bombers. Every week, 168. Every month, 720. And they were just one plant. One of 5. How do you fight that? How do you fight arithmetic? The lawyer had no answer. There was no answer. You couldn't fight arithmetic. You could only surrender to its inexorable logic. Ypsilanti, Michigan, 1991. Rosie Betts was 89 years old when the local newspaper came to interview her for the 50th anniversary of Pearl Harbor. She'd lived in the same house since 1946, a modest 2-story on the east side of town. Her husband Frank had died in 1967, never having spoken much about what he'd seen at Anzio. Her 3 children were grown, scattered to California and Florida and Texas, living lives that would have seemed unimaginably prosperous to their younger selves. The reporter, a young woman barely out of college, asked about Willow Run, about building bombers, about being Rosie the Riveter. I wasn't Rosie the Riveter, Betts corrected gently. That was a poster. I was Rosie Betts, line supervisor, Station 127. Very different thing. But you helped win the war? Betts considered the question. We built airplanes. Very good airplanes, very quickly. Whether that won the war, she shrugged. I suppose it did, in its way. But at the time, we were just trying to solve problems. How to install this component faster. How to reduce defect rates. How to make tomorrow's bomber better than today's. You don't think about winning the war when you're on the line. You think about getting through your shift. The reporter seemed disappointed by this answer. She'd come hoping for patriotic speeches, heroic narratives, greatest generation mythology. Instead, she got a woman who talked about production statistics and jig design with the precision of an engineer. Did you know what the bombers were doing? In Europe, I mean? Of course. We read newspapers. We saw newsreels. We knew our bombers were flying over Germany, dropping... She paused, choosing words carefully. We knew what they were dropping. We knew cities were being destroyed. We knew people were dying. German people, not just soldiers. Did we think about that while we worked? Sometimes. But mostly we thought about our brothers, our husbands, our sons who were over there, who were dying because Germany had started a war it thought it could win. She fell silent for a moment, looking at her hands, still strong at 89, still bearing the faint scars of metalwork. The Germans thought we were soft. Consumer society, women workers, democracy, they thought these were weaknesses. We showed them they were strengths. That's what Willow Run proved. Not that we could build bombers, but that our entire way of life, the free society, the market economy, the idea that ordinary people could be extraordinary when needed, that all of it was stronger than their regimented militarized system. So you're proud of what you did, Betts smiled slightly. I'm proud we solved very difficult problems under intense pressure. I'm glad we won. I'm sad it was necessary. Mostly I'm old. And I remember when building a bomber in an hour seemed impossible, and now I read that computers might someday fit on a desk, and I think nothing is impossible if you're willing to work hard enough and fail fast enough to learn. The interview ran on the back page of the local section. It included a photograph of Betts standing in front of what used to be Willow Run, now a GM transmission plant, the massive wartime structure repurposed for peacetime production, still contributing to American industrial might, still proving that factories aren't just buildings, but testaments to human capability. She died 3 years later in 1994, having outlived most of her generation. Her obituary mentioned her war work briefly, one line among many in a life well lived. It didn't mention that her innovation at Station 127 had saved approximately 4,800 man-hours of production time, contributing to the completion of roughly 60 additional bombers. It didn't mention that those 60 bombers had flown approximately 1,200 combat missions, dropped 9.6 million pounds of high explosive, and contributed to the destruction of German industrial capacity that made continued resistance impossible. The mathematics of contribution are always complex, always debatable. How much credit does one line supervisor deserve for the defeat of Nazi Germany? Some calculable fraction, certainly. But more importantly, she represented something that Hermann Göring never understood, and Albert Speer only understood too late. In a truly mobilized democracy, every worker becomes a weapon, every factory becomes a fortress, and every hour of production becomes a nail in tyranny's coffin. Willow Run produced 8,785 bombers, but its real product was proof that free people working voluntarily could outproduce slaves, proof that capitalism, for all its chaos and inefficiency, could outperform central planning, proof that democracy wasn't weak, wasn't soft, wasn't incapable of total commitment, proof delivered every 63 minutes in the form of a 4-engine heavy bomber for 2 years straight. The numbers tell a story that words struggle to capture. Willow Run alone, 8,685, B-24 Liberators, total American B-24 production, 18,482, total American heavy bomber production, all types, 34,934, total German heavy fighter production, 1942-1945, 11,346. Every 2 days, American factories built more heavy bombers than Germany built heavy fighters in an entire month. Every single month, the production gap widened. By 1944, the arithmetic had become so lopsided that German fighter pilots faced a simple, terrible calculation. Even if they achieved perfect efficiency, 1 bomber per sortie, no losses, they would still lose because tomorrow would bring more bombers than today's victories could account for. This wasn't war as practiced for millennia, where tactical brilliance or strategic genius or individual heroism could tip the balance. This was war as industrial process, where victory belonged not to the bravest or most skilled, but to the side that could sustain production longer, replace losses faster, and mobilize resources more completely. Germany had brilliant generals, elite soldiers, advanced technology, and a population unified by ideology and fear. America had Willow Run. In the end, the plant's greatest achievement wasn't any single bomber, any particular mission, any specific battle. It was the cumulative weight of possibility, the knowledge, shared by everyone from Adolf Hitler to the lowest German infantryman, that resistance was mathematically futile, that American industrial capacity was effectively infinite relative to German ability to inflict damage, that the war wasn't ending because Germany had been defeated in some climactic battle, but because arithmetic itself had rendered continued fighting pointless. 1 bomber every 63 minutes, every hour, every day, until victory was achieved or will itself collapsed under the weight of industrial inevitability. Göring was right about one thing. You can't fight arithmetic. You can only build a factory half a mile long and prove that democracy's chaos is stronger than tyranny's order.